Welcome back to Learning with Merit. Today we're going to look at the internet, specifically the client-server model. We're going to look in this video specifically, we're looking at the internet, the client-server model itself, locating the server, which deals with domain name system, and the uniform resource locators. We're going to look at sending the request and receiving the response. That's going to be HTTP request methods and HTTP response status codes. Alright, let's talk about the internet. First of all, the internet is just shortened from the phrase internetwork. Inter here meaning between. And so if we really put that together, it means we're between networks. But the idea is the internet is a connection of computer networks that spans literally nowadays the entire globe. And it's going to allow us to have communication and data exchange between all of our devices anywhere, literally, in the world, as long as we have a connection to to some network that has a connection to the internet. Now, to actually have a connection to the internet, if we look at our basic network diagram here, we have our little network, our basic network. We call this our LAN, and it sits right here. And what separates our LAN from the WAN side or the internet side is the router. And then we have we have one of these devices in our homes, either a modem or an ONT or an optical network terminal. And that's actually going to, translate the data. But sitting right here is the internet, right? And it's just a mystical little cloud on this picture. The internet is provided by what we call an ISP, right, or an internet service provider. Now, what they do is they're a company that's going to provide some sort of internet access for individuals, organizations, businesses, this type of thing. They maintain all of the infrastructure. This means like cables and towers and data centers that are necessary to connect all of these networks together. You can sort of think of it like a bridge, and that bridge connects your device to all of the other networks, right? So your network with your devices on it to all of the other networks that actually exist out there on the internet. We need somebody to provide that service because we cannot provide it for ourselves. Now, once we have someone to provide that service, what we can do is now we have the problem of, well, how do I send information from my network all across these cables through the internet connection here all the way to somebody else's router where they have stuff. Maybe I want to use their resources on their network. Well, now we need a model for that type of communication. Now, there are several types of models that we can use. And we're going to talk about perhaps the most important one, the client-server model. The client-server model, this is sort of the way that the most of the interactions that we as users have with the internet are going to occur. In the client-server model, it's actually fairly simple. What you have is you have a client and you have a server. The client over here is going to send the request to the server, and the server is going to send some sort of response back to the client. Now, the client is going to be any program or device that's going to initiate a communication session with our server. And that's going to send, request a service or some sort of resource. And in most cases, it's going to be a web browser. If we look over here, we have our laptop, desktop, tablet, phone, whatever device we're using, right? You could think of the device as the client, but it's actually more accurate to say that the web browser is the client. Because the web browser is a piece of software that sits on your device, the client device, and sends the request for us. Because without a web browser, we can't actually access the internet. When's the last time you used a device that didn't have a web browser on it? And we're using web browsers all the time. So the web browser is going to send a request, and we're going to get a response for the server. Now, the server doesn't necessarily have to be a device either. If we look at this, I'll drag over here, I sort of have a server rack to denote server here, but a server could be a computer program just like the web browser is. And in fact, most cases it is. We'll put a lot of different server programs on top of one server device. Right? Great example of this is we're going to talk about a web server. Right? And there are lots of different web servers out there. There's like there's an Apache web server. A lot of computer servers now these days will use something called Nginx. That's a web server. And there are a lot of different servers out there. You could have an FTP server for file transfer. I mean, there's just all kinds of different servers out there for what you're trying to specifically do. Okay? And those servers are going to send responses to our client over here, back to the web browser. So if we think about this, sort of what we have, we say, hey, I want this web page. So we send the request. The server says, okay, I'll find that web page for you. And it sends the response. And then in our browser, that file that we get back is then loaded into something that we can see and interact with. And that's the basics of the client-server model. There's some more details we're going to go into here, but basically it's just the request-response little loop we have going in here. We send a request, we get a response. Send a request, get a response. So now that we understand the basics of the client-server model, where we're sending requests and getting responses, now we need to think about some of the problems with this that we don't know yet, which are, for one, how do I locate the server I'm looking for? Well, to start by looking at that, I've got some different clients here. All of these are browsers, different browsers that you could use. And in fact, I want you to think about, when's the last time you used a device that didn't have a browser on it? Now, you may not know about all of the different browsers that exist, or what they do, or what the differences are, or why maybe you want one over the other, but you have used browsers. You've used them all the time. If you're on, iPhone, you may have used Safari. If you, have used any device these days, you've probably seen Microsoft Edge. If you work on Windows devices, you've probably seen Chrome as well. That's the Google's, flagship browser. If you work on Apple devices, of course, I talked about Safari already. If you're using Mac, you're probably using Safari on there. Right now, these are all browsers, all of them here. And Microsoft Edge comes default with Windows. Chrome is sort of built by Google. Brave is one that I really like. It is based on the same underlying stuff as Chrome is, and so is Edge. Edge is based on Chromium. So Chrome, Brave, Edge, and Opera are all sort of, I believe, Opera too. I know Brave, Chrome, and Edge are all based on Chromium, and I know Firefox is not. But the idea is you can basically do all of the same stuff you want to do in Brave as you could do with Chrome, or in Edge as you could do with Chrome, or so Chrome is not the only browser out there, although it is by far the most popular. But I also think a lot of people don't know their different options. You can get everything you can get out of Chrome in Brave, for example. That's my favorite browser. Okay? You can do the same thing in Firefox. You can get what you need to out of Firefox. These are all good browsers, and you should definitely look and see what these different clients here can provide you that maybe you're not getting in Chrome, because there are a lot of options out there, and it helps to know those options. But we're going to use Chrome for today because that's the easiest. Most everyone has had experience with Chrome, seen it before, and what we do in Chrome will translate very easily to all of these other browsers. So I'm going to open up Chrome here, and we will be greeted with sort of the startup page for Chrome. And you'll see Google, you'll see an address bar up here. Now, I want to be clear, this is an address bar, and most people use it as an extra Google search, right? And you can do that because most browsers build that in. But that's not actually what the address bar is for. Let's say I use it as a search, and let's look up something. Let's look up cats, right? So we look up cats, and it takes us to Google, and we've got pictures of cats and stuff on cats here, and you see cats in the little Google search bar. And we'll talk about search engines later as well, after we talk about browsers and all of the things that are going on there. But today we're going to look up here. And you may have noticed in the past, what the heck is going on up here? We've got a bunch of letters and numbers and equal signs and forward slashes, and it says like google.com, and maybe you know the google.com part, but the rest of it makes no sense to you. And what the heck's going on up there? Well, this is actually a part of how we locate the server in our browser. If I right click up here, I'm going to do something that you should do too when you're doing this, is always show full URLs, right? And I'm going to explain what a URL is later, but it's sort of the address up here. Now, the one that we all probably remember is www.google.com, right? That's easy. We call that thing a domain name, So let's break this down. Every device in a network, even a massive network like the internet, has an IP address. And this is the Internet Protocol address. This is how we send data across a network, right? So every IP address is not easy to remember. I can't memorize Google's IP address, and what if it changes tomorrow or next week or whenever, right? I can't memorize the IP address for this. And I dang sure cannot memorize all of the possible IP addresses for all of the different websites I want to go to. So we need a better system for this. Okay? And this system we end up calling DNS, or the domain name system. And a domain name is like this right here, www.google.com. That is a domain name. It's a human readable name for a website. Okay? It acts as a memorable or easy to remember address, and that allows us to not have to memorize numbers in, a random string here. Right? Now, domain names, the way that they are worked is you have to register them through something called a domain registrar. And there are a few out there. Let's look up domain registrars. And let's see who we have. So you can buy, there's Namecheap out there. Let's see. Google Domains, looks like you can buy them from there. There are a lot of different little registrars out there. There's Cloudflare. One that was really popular for a long time, I believe, was called GoDaddy. Let's see, GoDaddy. Let's see what that one is. So yeah, it was a popular one for a long time, and you may have heard about it before. But these are domain registrars, and they allow you to register a domain name and then map it to an actual IP address. Right? So we've got to have somebody to keep track of all this stuff, and you do actually have to pay for these. And so I own a couple of different websites, and I had to go through the process of registering the name and then pointing it to the server that actually hosts my website and all of that sort of stuff. So DNS, what is it? Let's actually look up a little tool here. I'm going to go up here. We're going to use the search feature. We're going to do NS lookup online. There are actually many different ways to do this. And let's see if I can find WebWiz. I like this one. So we're going to use this tool to NS lookup. And what it is we're going to perform the DNS function ourselves here by actually asking DNS to do its thing. Instead of just letting the browser do it, we're going to look it up and see what we got. So we need to translate the human readable name. Let's try www.google.com and tell it to run NS lookup. And what you'll see is we get several, and this is of course expected with Google. Google has a lot of different servers because there are a lot of different people out there who are using this. But whenever I ask it, hey, where is google.com at? It tells me here are the IP addresses that they are located at. Now in general, we don't want to use IP addresses. You can use IP addresses up in the actual address bar. I'll show you how to do that. So let's copy one. And you're going to see something funny kind of happen, I think. So I think I got that pasted. Yeah. And hit enter. And look at that. It took me to Google. Isn't that interesting? Now, it won't work for every IP address. And the reason is some websites are designed to be okay with handling the IP address, but others are not designed that way, and it's better to use their actual domain name. So it took me straight to Google using that little tool. So that's pretty cool. And that's exactly what's happening behind the scenes is you go and you look for google.com in the address bar. Well, your browser is going to reach out. Now, here's how this works. You type a domain name into your web browser, and then your browser is going to contact a DNS server. And this is usually provided by your internet service provider. Whoever they are, they usually provide you a DNS server. But there are other DNS servers. Let's look up some public DNS servers here. There are several. Google has 8.8.8.8 and 8.8.4.4. Okay. Cloudflare has one. They've got 1.1.1.1. Right? And those are some extremely common ones. And of course there's some more if you want to look them up. But these are public DNS servers that you can use instead totally free and instead of your ISP. So your browser contacts that DNS server, and then the DNS server checks its records for the IP address of the domain name. Now, if it finds it, it's going to send that address back to your browser. And then your browser is going to use that IP address to connect out. So basically, we did the same thing. We said, okay, I want to go to Google. Hey, give me the IP address for Google. Then we took it and we stuck it right there in the address bar and hit enter. And it took us straight to google.com, which is exactly what we wanted it to do. Okay? And we performed the job that the browser normally does for us very quickly. Okay, so think of it sort of like this. Domain names are like the names in a phone book, right? So in olden days, right, back before we had cell phones that did everything for us, we used to have a phone book. And in the phone book, there would be phone numbers and names associated with those. And if I wanted to, look up, somebody who I had met and I wanted to give them a call, I would go to the phone book and I'd look for their name and I'd find their number. And when I found that number, that's sort of like their IP address. And then the DNS server is sort of like the operator who looks up the phone numbers for you. So, way back in the time, you used to call an operator, and then the operator, you say, hey, I want to call this person. They'd look up the number and connect your call. So hopefully that sort of makes sense. We're going to translate this address up here into an IP address, and then using that IP address, we are going to go where we want to go. So now that we know the basic translation mechanism that we have in there, we need to talk about what is going on up here in this address bar. This thing is called a URL, or Uniform Resource Locator. And there's actually many parts to the URL that allows the computer to take us where we need to go and use all the right stuff and do all the right things. Right? And right now, this one's pretty simple. So let's talk about the basic design of this. First, we have a full domain name that sits right there that's highlighted. That's www.google.com. There are actually 3 parts of that. You notice that they're separated by periods. This one in the middle we actually call the domain. That's the name of the website, in this case, Google. And then to the right of that, we have .com. .com is a top-level domain. And this is the highest level category of a domain name. So when we sort of do the lookup, we start in the top level domain and work our way down from there. So we look in all the .coms and we look for Google. All right. And then over here on the left-hand side, the www part is what we call a subdomain, and it will not always be www, right? You have probably seen different ones. But anyway, these are domains that are within a larger domain, right? And they're sort of like adding a prefix to the existing name. For example, mail.google.com is a subdomain of google.com. Then we have this part right at the beginning, which is https://. Now what this is this is the protocol. And the protocol tells us how we're sending the actual data. Now, HTTPS is really the only protocol today, but there used to be one before back in the day, way in the past, right, for the internet, and called Gopher, and it was literally Gopher. It was the Gopher protocol, and so it would be Gopher : www.google.com. It literally looked like this, and there are actual websites. Whoops, if I type it out right. There are actual websites that use the Gopher protocol, and you should actually look that up. It's actually pretty interesting. There's some websites you could take a look at that way. Anyway, so the point is we have the protocol, and then we have the full name, we have the subdomain, the actual domain, and then the top level domain, and then the full thing, we call that the domain name together. Now, when we looked up cats, there were some other things going on there in our protocol. So, ooh, look at that. After that, we get all kinds of gobbledygook going way out here. All right, there's a lot of stuff going on there. But we can actually break it into parts, and it's not that difficult to understand. Let's see if I can get back to the beginning. So if we look after our domain name here, the next piece that we have, normally, I'm actually going to add it this time. Let's see if they actually use 443. I believe that they do. Yeah. it automatically removes it. But you could put something here like this. So we do :443, and that is the port number. And we've talked about ports in the past, but if you don't know what a port is, excuse me, it's a software-defined number, right? And that's going to be assigned to a unique connection endpoint on the server, right? Then that's where we're going to send data or ask for a specific service or resource, right? It's a specific number that is tied to whatever thing we're looking for, in this case 443. And the reason I knew 443 is because the default port for the HTTPS protocol is 443. So if we are going to a web server, they're usually going to provide that service on port 443, and we're going to connect to it with the HTTPS protocol. Now, it doesn't have to be 443, but most of the time it is. So if we added that, we would add a colon and 443 to specify the port. And if you have one where you know it's not the default port, you have to specify in the URL for it to actually connect and use it correctly. So now that we know where the port goes, well, what's after this? What's this thing right here? Well, the next piece is the file path. And the file path is going to tell us the exact location of the file inside the website's directory structure. So somewhere we have the root directory for the web server, and inside of that there's going to be a search folder, right? Or some sort of search file, right? The point is here, that is our root. We also use that to separate the file path as we go. Then we're in the search directory, and then we have this stuff right here, this little question mark. That is called the query string separator, right? And it's a delimiter, meaning separator is what that really means. And it separates the main part of the URL from the query string. Now the query is sort of like extra data about the request. In this case, I'm asking a question to Google, really. I'm saying cats, right? Show me cats. Show me stuff about cats, right? In this case, that's what that little Q equals cats, right? That's our query. So this whole thing after that question mark, all of what you're seeing is a query. And there's a lot of stuff going on there. You see ands, you see things equal to other things, and stuff like that. Now we could go real in depth into what that is, but it's not super important to your understanding, at least at the moment. Okay, but all of this after that is just extra data about our request that we're making to the actual computer. All right, we're sending all of that information to the server, and we get a response that gives us a page that looks like this from Google. All right, so we know what a URL is now. We know how we find our server. We know how we send the address and use the address and all the pieces and parts of that address, right? And we could even look at that address right now. So we've got a different website here. We've got the protocol HTTPS. We are at the subdomain developer, on the domain Mozilla, on the top level domain .org there. And then in the file path, this is where we are at. So, and of course we don't have any query string here this time. It's just, this is the file path, and this is what they are showing us from that file path. So we're in English US, docs, web, HTTP, and methods there. And we're going to talk about these HTTP request methods, but it might be helpful to know what the heck is HTTP first of all. And I mentioned it earlier, but let's talk a little more about it. It's a protocol designed for transmitting information, specifically web pages, between a web browser and web servers, right? So we get a response from the web server, and it sends a page to us. Typically for HTTP, that's port 80 it's sending it to, and that's going to then be provided to us inside of the page. So literally when I try to go to this website, it reaches out, it sends a request to the server at this location, right, for this file path, right, and it asks me for the web page that sits there, and the server is going to send that back to me, and whenever the browser gets that information, it then builds this page so that I can see it and interact with it. And that's the whole process there. That's our client-server model. So remember that HTTP is usually on port 80. HTTPS, though, now that one's a little different. That stands for Hypertext Transfer Protocol Secure. And what that is, it's the HTTP protocol on top of an encryption layer we call Transport Layer Security, or TLS. And that's going to provide the information, that's going to protect the information traveling over the internet. Now, used to, we didn't know any better, and so we didn't have that layer of encryption like we needed to. And over time, as we've improved our security, we've started using HTTPS to protect the connection between the 2 points. Now, there's something we need to know about before we get into the methods too deeply, and that's what we call HTTP header. Now, HTTP headers are lines of text that provide additional information about an HTTP request or response. And so we have that request response thing that we got going on, but maybe we need plenty of information whenever we're doing stuff, because we need to know what we're requesting and all that sort of stuff. And then our response, we need some information about the response. Maybe there was a problem, maybe there wasn't, whatever, right? And we get something we call metadata. And that's kind of what the HTTP header acts like. Now, metadata is extra data, right? It's extra information. And you actually don't usually see it when you're looking at the browser. It's sort of hidden from you because it's not important to displaying the web page. So in this case, we are going to take a look at some request methods, and then we're going to take a look at some headers and some information that we get from that. There are two very important methods. Now, one of these important methods is get. And this one is literally what it sounds like. Get this. It's there for retrieving data. And it does it in a specific way. It is only there for getting, I'm going to use that word a lot, for getting the information. That's the only thing it's there for. Right? Now, we have some other methods, but the other one that's also important that I want to point out is the post method. And this one submits something. So if you want to change something or cause an effect on the server, you do a post method, right? So you get to receive information from the server, and when you're posting, you're sort of sending information to the server. Those are the two different main states. Now, there are some other ones that we have here, and of course we could read through them. So you got like the head method, ask for a response, identical to a GET request, but without the body. So it just gets the headers, right? You've got the put method, which replaces all of the stuff of a target resource with the request payload. So whatever we're sending, right, it's going to put that on the server. We have delete to remove things, right? And of course you can read through all of these, and some of them are supported by all browsers, some maybe not, that sort of thing. But get and post are going to be very important. They show up quite a bit. Put and delete, I would also say, show up quite a bit and are fairly important. But those are going to be our requests. And at least in the beginning here, we're going to either get or post. We're either going to be retrieving the data, or we're going to be trying to change something on the server to make a change. Right? Now, we need to talk about responses as well. But before we do, let's take an actual look at a GET. Right? So I have a website here that I really like. It's called httpstat.us, and it gives us status codes, and it allows us to do a lot of things. And what we're going to do is we're going to look at some developer tools here. So in every browser, usually there are some tools, and I'm going to find more tools down here, and this is called developer tools. And you've probably seen this before because you accidentally hit a button and then this weird thing pops up and you're like, what the heck is all that? That looks like a bunch of code and stuff. I don't know anything about that. That's going to be your developer tools. And you can use Control-Shift-I to open it up on a web page. You can do what I just did by clicking this little 3 dots up in the right-hand corner, scrolling down, finding more tools, and then clicking on it. You can also hit F12. These are all appropriate ways to get to it. So I'm going to click on Developer Tools here. And you're probably going to start here on Elements whenever you open it up. You're going to want to look for Network here in the middle. I'm going to click on that. I'm going to get rid of this stuff down at the bottom because it's just sort of in my way. All right, and one of the other things I like to do is this can sort of get in the way, so maybe you want to take it and undock it, so give it a separate window. That way you can move it around. So I'm going to stick it right here after I undocked it, and the way I did that was these 3 dots right here, and then I clicked this one right here. There's also some different pane options that you can do. But let's try a simple one here. So I'm gonna do /. See, I'm gonna edit that web URL up there and give it a page I want it to go to. So this is a special response code. Now this website is designed to give you the response code that you asked for, and this is great, a great little tool for learning about this, because it will give me the response code that I want just by editing this. This is not how it works in every website, just how it works on this one. But if we look at this, here I have this code right here, and I can see headers. And I'm going to click on raw for both of these so I get the raw data to look at. And I'm going to make it full screen. If we look at this, here's what I did. I had a request URL, which was this. And the method that I used was a get. And if we look at the response header, so here's what we got. My request looked like this. I said get this. And then this is all that header information that we talked about. It even includes things like a cookie and what host we're looking for. And anyway, this is all that information that's important that gets sent in a request that, heck, you didn't even know was getting sent. Right? So that gets sent in the request. So it's get, and we're looking for that page. And looks like the response made it there, and then, or I'm sorry, the request made it there. And then the response we get is this right here. And it sends us this code. And that says 200 OK. And it might be nice to know what 200 OK means. So let's go ahead and move this. You also see that's green, so it's probably good. Oh, and you'll also see something else. Look at this. You'll see the remote address. That's our IP address with a port number. Would you look at that? That's pretty cool. So that our DNS lookup did its job. So I'm going to go ahead. Let's minimize that. Let's come back over here. Let's look at some of these response status codes that there are and see what there are. So we've got informational responses, successful responses. We got a 200. So that's going to be 200 through 299. Let's see if they've got that on here. Let's find 200. Oh, there it is. 200 OK. The request succeeded, and it meaning success. So we got what we wanted from it. The request succeeded. Let's change it to one. Let's do a 400 request. I'll hit enter on that. This one says bad request. Let's do the same thing. Let's look and see what we got. Well, there's our 400 request. I'm going to look at the raw data from both of these. Our request header, of course, we got everything that we were sending and trying to request there. And then what did we get? Well, we got a 400 bad request response. And of course, once again, we see there's our URL. There's the actual IP address that we're going to. And then here is the status code that we received. And it's, of course, in red, meaning it's a bad request. Now, 400 codes. What are the 400 codes? Well, let's take a look. If we scroll up here, looks like the 400 to 499 are all client error responses, which means the client side is probably the issue. You sent a bad request, or you were not authorized, or let's take a look at a few of those. We scroll down all the way here, and let's look. Okay, so we've got 400 for bad request. That's the one we just did. There's 401 on authorized. That's meaning you did not get authenticated, right? So you didn't prove that you were allowed to have access to that. There's 402 for payment required. 403 forbidden, meaning you don't have access rights. 404 not found, one of my favorites, right? This means that what you were looking for doesn't exist. Okay, and of course there are a lot more that go into there, and you can read about all of these different client error codes. Let's look at a different one. Let's change this. We're going to do 500 this time. 500. So 500 says internal server error. If I pull this up and let's look at the information for it, I'll click on raw again. We'll see, oh, look at that request we wanted to get, and This is the file path we wanted to get. And then our request was an internal server error. Of course, the same stuff we've looked at. We were using the get method each time because we were just wanting to retrieve. We weren't trying to change anything. All right, if we look back and we look at those codes, what are the 500 codes? Well, I can tell you the 500 codes are going to be server error responses. So what this means is the error is probably on the server side. These are super useful for figuring out what's going on, what's wrong. Is it my side that's causing the issue? Is it the server side that's causing the issue? Why can't I access this website today? Right? Is it a client error? Is it a server error? What's going on there? Right? Is everything perfectly successful? Is it working like it's intended to? So these are our response codes. So we have the methods that we use to send a request, like get and post, and we have response codes that we get depending on what actually occurs at the server side. And so all of this is normally hidden from us. And we can't see it unless we use something like the developer tools here to actually look at that information and maybe track down what's going on, and especially help us find things like the remote address that we're connecting to. That IP address can be very useful to you. You can see a preview of the information. You can see the response. There's some other things in here. You can also look at some of the cookies. We'll talk about cookies in the future. And cookies are interesting things as well. So in this video we covered the internet. We talked about that it means between networks, and we are dealing specifically here with all of the infrastructure between those networks so that we can connect to someone else's router and they have all the stuff that we're looking for here. Right? We talked about the client-server model. On the client-server model, we have the client, which in this case is typically going to be our web browser's piece of software that is on our personal little devices. It's going to send a request, and that's going to go to a server, which is going to send a response from that. And that is our client-server model. Now, when we go about locating that particular server, we might have our browser here, and in that browser we're going to have some sort of domain name up here like www.google.com. If we go to a lookup tool, we can actually do this. We enter whatever website we want, www.google.com, just like that. We run the NS lookup, and it will provide us with IP addresses for google.com at that time. And they may change. They change all the time. Now, after that, we have what is called a uniform resource locator. Those are these things up here at the top. And they include things like the protocol, the subdomain, the domain, top-level domain, and then file path of whatever we're looking for. And in some cases, like with Google, we will have a query string separator. So if we go to Google here and we search for cats, you will see we have a query string separator and then a query to go along with that. It's extra information about what we're trying to do. And of course, while I didn't mention specifically, hackers will manipulate this quite often in order to get websites to do things that they shouldn't do, or go to parts of the websites that they shouldn't be able to go to. Then if we are sending or receiving requests, we are dealing with HTTP response methods and HTTP response codes. And if we look at those, we can actually take a brief look here. These are our request methods. We talked about the get and the post method. Get to retrieve data, post to actually change something about what's going on the server. And then our server is going to send us some sort of response. We look at that, we have response codes. Anything in the 200s are going to be successful responses, 400s are going to be client-side errors, server-side errors are going to be the 500 codes, and that is what we're looking at there. So everything revolves around this client server model. We are sending requests, receiving responses. We are doing so using domain names, which are translated using the domain name system into IP addresses to actually connect to the servers that we are looking for. I hope that you learned something, and I appreciate you watching Learning with Merit.